Every time you ask an AI to write an email, generate code, or answer a question, you're making a transaction. You send a query, and you get a slice of artificial intelligence back. But what most people don't realize is that this intelligence has a rapidly growing and often unpredictable price tag. Companies are spending millions, sometimes hundreds of millions of dollars a year, just to power their AI applications. They're caught in a brutal dilemma. Use the most powerful, genius-level AI models for everything and watch costs explode, or cheap out on weaker models and risk a clunky, frustrating user experience. It seems like an impossible choice. But in 2025, a new piece of technology is quietly solving this billion-dollar problem, acting like an intelligent traffic cop for AI. It's called an AI router, and it's the secret weapon that's slashing the cost of intelligence, in some cases by over 90%, without sacrificing quality. This isn't just about saving money, it's about fundamentally changing how we build and interact with artificial intelligence. So, how does this intelligent switchboard work? And how is it deciding which AI gets your question? To really get why AI routers are such a game changer, you first need to understand the hidden battlefield of AI costs. Think of large language models, or LLMs, as a fleet of cars. You have your Ferraris and Lamborghinis, models like GPT-4 and Claude 3 Opus. They are incredibly powerful, capable of nuanced, complex reasoning, and can handle almost any task you throw at them. But running them is like filling up a supercar with premium fuel. It's astronomically expensive. Every single query, every API call costs a significant amount. Then you have your reliable sedans and compact cars, smaller, more specialized models, maybe an open-source model like Llama 3, or a fine-tuned version for a specific task. They are incredibly efficient and cheap to run, but they aren't built for high-performance, complex challenges. You wouldn't take a compact car to a racetrack and expect it to compete. For years, companies faced a black-and-white choice. To guarantee quality for every user request, they'd often just default to the Ferrari model for everything, from answering a simple "what's the weather" to writing a complex legal analysis. The result? Insane spiraling costs for tasks that a much cheaper model could have handled perfectly. This created a massive unspoken inefficiency at the heart of the AI revolution, a problem that was practically begging for a smarter solution. And that solution required building something that could act as a brain for the entire AI ecosystem. A system that could understand the difference between a joyride and a Grand Prix. Enter the AI router, or as it's often called, an LLM Gateway. Think of it as a highly sophisticated, intelligent switchboard operator sitting between an application and a whole library of different AI models. Before AI routers, an app was hardwired to a single model. If that model went down or got too expensive, you were stuck. But a router changes the game entirely. When your request, let's say, summarize this 100-page report for me, comes in, it doesn't go straight to a specific AI. First, it hits the router. The router's job is to instantly analyze your request and act as a super smart dispatcher. It looks at your query and asks, how complex is this? What is the user's actual intent? Is this a simple question, a creative task, a coding problem? Based on that analysis, it intelligently directs or routes the request to the best possible model for that specific job, balancing three key factors: performance, cost, and speed. So a simple question might get sent to a fast, cheap model, ensuring a quick, low-cost answer, but a complex demand for a detailed business strategy would be sent to the high-performance genius model, ensuring the highest quality response. This system also builds in incredible resilience. If one AI provider, say OpenAI, is having an outage, the router can automatically reroute the request to a different but comparable model from another provider like Anthropic or Google, ensuring the application never goes down. It's a simple concept on the surface, but the technology behind how it makes those lightning-fast decisions is where things get truly fascinating. The magic of an AI router lies in its routing strategies, which have become incredibly sophisticated. In the early days, routing was pretty basic. Developers would set up simple deterministic rules. For example, any query containing the word translate would automatically be sent to a translation-specialized model. Any request with the word code would go to a model trained on programming languages. This was effective but rigid. What if a user asks, "Can you explain this Python code?" and then translate the comments into Spanish? A simple rule-based system would struggle. This is where things in 2025 get much more advanced with a technique called semantic routing. Instead of just looking for keywords, a semantic router uses a special kind of AI called an embedding model to understand the meaning and intent behind your words. It converts your query into a string of numbers, a vector that represents its place in a vast semantic space. Think of it like a giant multidimensional library of ideas. The router does the same thing for all the AI models it has access to, creating a profile for each one that describes its strengths and weaknesses in that same semantic space. When your query comes in, the router doesn't just match keywords. It finds the model whose capabilities are the closest semantic match to your request's intent. If your query has the semantic flavor of a complex financial analysis, it will be matched with a model that excels at numbers and reasoning, even if you never used the word finance. This allows for incredibly nuanced and dynamic decision-making. The router can learn and adapt, continuously monitoring the cost, latency, and quality of the responses from each model to refine its routing strategy over time, getting smarter and more efficient with every query it handles. This isn't just theory. Companies are already using these systems to achieve mind-boggling results. The impact of implementing AI routers has been nothing short of transformative. The most immediate and dramatic benefit is, of course, cost savings. By intelligently diverting the majority of simple, high-volume queries away from expensive models, companies are reporting massive reductions in their AI operational expenses. Some open-source frameworks have demonstrated cost reductions of over 85% on certain tasks. One company, airrouter.io, reported that its beta users saw an average of 58% in cost savings in just the first week. But one of the most cited examples comes from Martian, a leading commercial AI router provider. They worked with a customer service training company that was exclusively using the powerful but pricey GPT-4 for all its needs. By implementing Martian's router, the company was able to achieve a staggering 300-fold cost reduction while actually improving the quality of its AI's responses. This highlights the second major benefit: enhanced performance. By sending the right task to the right model, the overall user experience gets better. Simple queries get near-instant responses from faster models, reducing frustrating lag time. Complex queries get the high-quality, accurate answers they require from the powerhouse models. It's the best of both worlds. Furthermore, this technology future-proofs a company's entire AI stack. An AI router provides a single, unified interface to connect with dozens or even hundreds of different LLMs. This means developers can easily experiment with and swap out models without having to rewrite their application's code every time a new, better model comes along. It creates a flexible, resilient, and adaptable system that can evolve as quickly as the AI landscape itself. So, if this technology is so powerful, who are the key players building these intelligent systems in 2025? The AI router market in 2025 is a vibrant ecosystem of both powerful commercial platforms and robust open-source projects, catering to everyone from massive enterprises to solo developers. On the commercial side, a few names stand out. Martian is one of the pioneers, offering a sophisticated model router that focuses on dynamically routing prompts to achieve the absolute best performance at the lowest possible cost. Their technology is trusted by major companies and has been backed by significant investment from firms like Accenture. Another key player is Portkey, which provides a comprehensive AI gateway focused on reliability and developer experience. It offers a universal API to connect with over 200 LLMs and includes powerful features like caching, load balancing, and automatic fallbacks to ensure applications are always running smoothly. For those who prefer more control and want to avoid vendor lock-in, the open-source community has delivered incredible tools. Light LLM has become exceptionally popular, offering a lightweight yet powerful way to call over 100 different LLM APIs using the exact same code format as OpenAI. It's simple to set up and gives developers a unified interface to manage all their models. Other projects like Root LLM offer pre-trained open-source routers that are proven to slash costs while maintaining high performance. Whether a company chooses a managed commercial solution for its ease of use and enterprise-grade support, or a flexible open-source tool for its customizability, the core benefit is the same. They are moving away from a rigid, single-model approach to a dynamic, multi-model strategy. This isn't just a new tool. It's a whole new philosophy for building with AI. The era of relying on a single, all-powerful AI model is officially over. The relentless race to build bigger and bigger models is being replaced by a much smarter, more strategic race to build better orchestration. AI routers are the heart of this new paradigm. They are the invisible infrastructure making artificial intelligence more accessible, affordable, and reliable for everyone. By acting as an intelligent switchboard, they solve the crippling dilemma between cost and capability, allowing for the creation of sophisticated AI systems that are both powerful and sustainable. The future of AI won't be defined by a single winner, but by the intelligent interplay of a diverse ecosystem of models, each contributing its unique strengths. It's a future that is not just intelligent, but intelligently orchestrated. If you found this look into the future of AI infrastructure interesting, be sure to subscribe for more deep dives into the technology that's shaping our world. Thanks for watching.